Welcome to Lesson 8. I can use the area model and multiplication to show the equivalence of two fractions. So Lesson 7 introduced us to this topic, and now we're going to go a little deeper into using multiplication and area models to show equivalence of fractions. Okay, this one says, use multiplication to show equivalent fractions. Before we can do that, let's figure out what is the fraction we're starting with. So let's look. We have this big rectangle here that I'm outlining for you. And we see that it's divided into three big compartments. Okay, so we have one big compartment here, we have our second one here, and our third one here. So we have three big compartments, or three total parts. So we know from our previous lesson that if we have three total parts means that is our denominator. So we have our denominator at the bottom with our fraction bar above it, and then we look and say how many of the total parts are shading. We can see we have two total parts shaded. So the fraction we're starting with is 2 over 3, or 2/3. And that's the first step you have to do when using multiplication to show an equivalent fraction when they give you an area model, is to figure out what is the original fraction you're starting with. So then we can use multiplication to find an equivalent fraction. Now this one, they divided it up so that now each larger compartment is divided into three separate, smaller parts. What is that telling us to do? Well, we need to multiply by what number? Well, if we made it into three separate, smaller groups, we can multiply by 3, which equals 6. And again, in Lesson 7, we said whatever you do to the bottom, you must do to the top, or vice versa. So whatever you do to the top, you must do to the bottom. So we multiplied our numerator, which is our top, by 3, and we got 6. Draw in our fraction bar. And we are going to multiply the bottom by 3. And we get 9. Now, I didn't write a fraction bar last time when we multiplied. There's a reason today when I multiplied by 3, I put a fraction bar in between my 3's. The reason I did that is to show you, because we know from previous lessons that 3 over 3 equals 1. So what I'm showing you now is that when you create an equivalent fraction, you're multiplying by the same on the top and bottom, which is also saying you're multiplying by 1. So although the fraction looks different, it means the same. And in the last lesson we talked about, you still have the same amount of pi, but it's just in a different sized piece. Okay, draw a model to represent 5/6, and find an equivalent fraction with a denominator of 12. Okay, so all we have to do is draw a nice model. And it does not have to be perfect. What you want is that you want it to be as close to, your boxes should look pretty close. I made thirds, and I know that 6 are half of 1/3, so I can just divide those in half, and now I have nice, 6 equal parts. And I made 6 parts because it says 5/6. So I know I have 6 total parts. And since I have 5 of them, I now shade in 5 of them. Keyword is 5. So erase that. Alright, so now we have 5 shaded parts. Now it says we need to get a denominator of 12. Well, let's think. If I have 5 over 6, what can I multiply the top and bottom by to get my answer? Well, we don't know quite yet the numerator, so I'm going to stop because I don't want to put a number up there because I'm not quite sure. I thought I knew, but I'm not quite sure. So I'm going to go to my denominator. I know I need a denominator of 12. So 6 times what gets me 12? 2. So 6 times 2 gets me 12. So now I know I must multiply the top by 2, and that also equals 10. That equals 10, excuse me. So now we have a new fraction, 10/12. And I can finish my model because we multiply by 2, so that means I only need to make my model into 2 parts. So I draw a line, and now you can see we have 12 total parts and 10 are shaded in. Okay. Is 3/4 equal to 6/8? Well, pretty simple. We can draw a model to prove it's true, or we can use multiplication. So let's see. 3 over 4 times what gets me 6? 3 times 2. So now I have to multiply the bottom by 2. Because what I do to the numerator, I must do to my denominator. Put my fraction bar in between. Is 3/4 equal to 6/8? Yes, we just used multiplication to prove it. Is 3/4 equal to 6/12? Well, again, let's use multiplication to see if this is true. 3 times what equals 6? Well, we just said it was 2. So, 3 times 2 equals 6. 4 times 2, well, we just said it equaled 8 in the previous problem. So, we know 3/4 equals 6/8. It has 6/12, so it's false. And that's all you have to prove. If you multiply the top, the numerator, and the bottom, denominator, by the same number, and you match these, so you got this correct, but then you go to your denominator and you go down here and you see that it does not match, you proved it. You can move on. Find an equivalent fraction for 3/5 without drawing a model. Well, this is easy. 3, 5, times what? What number can I always multiply by? When it says just to create any equivalent fraction, what number can I always multiply by? That's real simple. 2. Always multiply by 2. And that gets me 6. And multiply the bottom by 2. And that gets me 10. So 3/5 equals 6/10. Really simple. I know some of you might think it's cool to multiply by 10, or by 5, or by 8, or by 12. But if it says make any equivalent fraction, multiply by 2 and make it easy for you. Alright, let's look at these. On your problem set, it says the shaded fractions have been decomposed into smaller units. So again, on lesson 7, it started out with 1 out of something. 1/4. 1/2. 1/2. We saw a pattern, right? It was 1/2 for most of them, and the last one they threw in a screwball and had 1/4. So these ones now are starting off differently. So this one, for example, letter A, it starts off with 2/3. So we see the entire rectangle is here. It's divided up into 3 parts. So that's why we have 3 as our denominator, and we have 2 whole parts shaded in. When we divide it up into 2 smaller parts, now we see Then we multiply the numerator and denominator by 2, and that gets us our 4/6 right here. So for this one, we're starting with, well, we have 1, 2, 3, 4 total parts. So my denominator is 4, and I have 1, 2, 3 shaded in. Now they divided it up into 3 smaller areas. So now I have smaller parts of 1, 2, 3. So I can multiply by 3. And is it okay for me to do times 3 times 3? Yes, it's okay to do times 3 times 3 because, as we stated, and I will state multiple times, you multiply the numerator and your denominator by the same number when finding equivalent fractions. 3 times 3 is 9, 4 times 3 is 12. Let's look at this one down here. Let's go to D. We don't need to do all of them. We're going to jump down to D. And we see we have 1, 2, 3, 4, 5, 6 total parts. So I have 6 as my denominator, and then I have 5 shaded in, so 5/6. And they only made it into 2 smaller parts. So now I know I multiply by 2. The numerator and denominator by 2, and I get 10/12. Number 2 says, decompose the shaded fractions into smaller units, as given below. Express the equivalent fractions in a number sentence using multiplication. Decompose into tenths. Well, okay. So we start with, how many do we have? We have 5 total. So again, my denominator is 5. I have 3 shaded in. 1, 2, 3. Okay? I want to get into tenths. What number is going to get me tenths for my denominator? Well, 10. So I know that 5 times something, so 5 times something is going to equal 10, which is 2. So now I know I must multiply my numerator by 2, and 3 times 2 equals 6. And if I draw my line across, there we have it. We just decompose the shaded fractions into smaller units. And 3/5 equals 6/10. Okay. Again, now this one here says draw area miles to prove. But we've kind of worked with area miles already, so what I'd like you to do is to just write out the fraction and give yourself some more room. Times blank equals. Okay, I would like you to use multiplication, because we can draw the miles, but miles take time. And if we can multiply to solve it, then we can get our answer faster and we can move on. And if multiplication is something we already know how to do, then do the easier route. So 2 times what gets me 4? We have 2. And if I forget that 5 times 2 equals 10, we shouldn't, but if I forget, well, I already know that I have to put a 2 here because I multiplied by 2 in my numerator, so I must multiply by 2 in my denominator. 2/3 times blank and times. So 2 times what gets me 8? 4. So I know that I must multiply my denominator, by 4 to get 2/3 equals 8/12. And there you have it. That is lesson 8 of module number 5.